Okay, good morning, PDC. Good morning, and thank you for waking up early on this fourth day of PDC and coming to this session. My name is Gianpaolo Carraro. As many of you might have guessed, I'm Italian, which explains the sexy accent. And I work in Redmond, and I lead a team of architects. And we've been spending the last, I would say, 12 months, really our head in the cloud. Meaning that we've been accessing a lot of the technology that you've been seeing in the last few days in the early stages. A lot of things didn't work. Could say that some things still don't work, but at least we're there now. We're public with a lot of good stuff. And my role and my team's role in the last 12 to 6 months was really to understand what was the architectural impact of these new technologies that we're bringing to market today. So, first of all, I would like to, if I click the right button, to welcome you. And really, this is a pleasure for me to share with you a lot of the learnings that we've done over the last 6 months, 12 months. I would be very happy at the end of the day if the 12 months or 6 months of hard work we've done will help you accelerate the understanding of the cloud. It took us a lot of time to really understand the nuances between what was possible before and what is possible now. If by spending a few hours with us, you basically accelerate by a week, by a month, by 2 months, your understanding, this is basically what I would be happy with. What you'll be happy with, I don't know. We'll see at the end of the presentation with the evaluation that will return. But really, what we decided to think about this symposium, we realized that we would have been the fourth day of PDC. And so far, you've seen 4 keynotes, 120 sessions, thousands or hundreds of demos, maybe 3,000 slides. You've learned about C#, F#, Strata, Oslo, Windows 7, Surface, you name them. What is left to talk about? Well, what we thought was left to talk about is this. A lot of the sessions at PDCs are conceptually about the individual pieces, understanding individual technologies per se, going very deep in each of them. What we propose we do today is thinking about the puzzle, thinking about those individual pieces together. So we will not be going as deep as many other sessions you might have seen, but hopefully we will be able to go wide enough to start introducing why some technology work with others, why some technology should or should not be used with others, how to think about a solution end-to-end, and what does it mean to use this in the context of this other thing. So really, at the end of the day, this symposium is a journey, if this worked, through multiple perspectives. It's not going to be only about technology. It's not going to be about coding. It's not going to be about showing you all the Visual Studio wizardry that you can do with the technologies. There will be some of that, but it's not going to be only about that. The first session, which is the one I will be presenting shortly after this introduction, is really a first introductory session about the cloud as a whole, how to think about it. How to think about it if you're an enterprise, how to think about it if you're an ISV, and also, we will also going through some early emerging patterns that are specific in a cloud environment. So it would be more about architecture, more about what to use when. The second session that will be presented by a colleague of mine, Eugenio, will be going into more the coding aspect of the cloud and really going into the how. Opening up Visual Studio, showing how access control is working in conjunction with the Geneva framework, how SDS and Windows Azure work together. So really going into the more specific element, building upon the models, if you will, that we will have discussed in the first session. Finally, the third session will be a much lighter version. We realized that the third session would be the very last session of the PDC. So we said, well, what the hell? Let's have some fun, and let's have a more conversational presentations where we will be going to ideas beyond technology, thinking about some of the business impact, some of the business models that are emerging, but also looking at some of the physical constraints that some of the people today are not familiar with because they are working in this special environment called the enterprise data center, where failure is not really relevant, where most of the network is over LAN, which basically forces or confuse people in thinking that bandwidth is infinite and free. So we will be looking at what the cloud and its particular environment means from a physical perspective, from a business model perspective, and also some of the policies and regulation that are relevant now that this world becomes distributed. Those sessions are meant to be self-contained, so you can come to any of those sessions independently. But obviously, we believe that if you stay for the entire day, the entire symposium, you will be getting a better picture because each of those sessions are referencing each other. But once again, if there are other sessions that makes a lot of sense for you to go in between, feel free to do so. You feel free to jump in and pop by for the last one or miss one and things like that. Does this make sense? I'll take that as a yes. And let's get started with the first session. Expanding applications to the cloud. As I mentioned, we will see the enterprise perspective of it. So first, show of hands, how many of you are from enterprise IT? About half, which is good. Who of you is from an ISV? The other half. And OK, very good. So there will be a bit for both. The first session will be for the enterprise, which I think is very interesting for ISVs because they will understanding maybe what the enterprise thinks and basically maybe prepare and build applications that are more tuned to their perspective. And the second part of the presentation will be for ISV, which I think is very interesting for enterprises, which will help them understand how ISV will approach the cloud as a whole. I want to leave enough time at the end for Q&A. I think this presentation will open a lot of questions that might not be all answered. So that would be a good opportunity to have a conversation at the end. So when I prepared for this session, one of my presentation coach said, hey, you need to engage the audience. So I said, well, let's engage the audience with a quiz. I don't know if it's the best way to engage the audience, but at least it's an attempt. So I'm going to show you two pictures, and you're going to tell me which one is better. You have the very cool, or depending who you know, from an Italian perspective, not as cool car on the left-hand side, and you have a train. And I tell you, you need to go from one place to the other. Which one do you use? You don't have to answer. You don't have to show a hand. Just think about it in your head. And I'm going to give you a little hint. The car with 1 gallon of fuel, or 4 liters for the non-American people, can move a quarter of a ton, or 250 kilos, over 20 miles. A gallon of fuel used in a train can move a ton of freight over 436 miles. Well, that gives us a clue in which one is better. But obviously, if you use the car, you can go anywhere, anytime, and the road system is much more complex and diversified than the train system, and it's ready to go anytime. The train, on the other hand, can mostly go from A to B and leaves only twice a day. So what I'm trying to say here, maybe too much simply, is that which one is better is really dependent on what you want to optimize for. If you want to optimize for control, the car is obviously the right way to go. If you want to optimize for economy of scale, the train is what you want to use. So this notion of control versus economy of scale will come over and over throughout the day. It is one of the most important trade-offs that you will have to think about when you want to embrace the cloud. When you think of it, actually, this is not new. When, as an enterprise, you were thinking about buying or building software, this is very much the choice that you were making. Do I want to build my own software with my own team and control the feature set of my application? Introducing features that are not available commercially out there? introducing features that differentiate my application from others? Or do I want to buy a packaged software where I can take advantage of the scale of the software vendor? The software vendor puts R&D into the software package and divide that R&D among the hundreds, if not thousands, of customers of his. An enterprise puts the R&D for building their own software, and the only economy of scale they get is themselves. The R&D that they have is divided by their own usage. What is new now with the cloud is this notion of on-premises versus in the cloud. So the same way you were thinking about buying versus building your software, enterprises will start thinking about deploying on-premises or deploying in the cloud. And those two dimensions, if you will, are actually complementary. Those two dimensions are pretty much orthogonal. So you can think of on-premises as three choices. The on-premises, I buy my own hardware, I manage my own environment, I really control the SLA that I have on my data center. I want to point you that controlling the SLA does not mean you're doing a better job than others. It just allows you to decide the SLA that you want. You want more, you invest more. Less, you invest less. If you take another deployment choice, you will be deciding and accepting the SLA of that particular deployment model. So there again, control on the environment. You have this potentially intermediate step, which is a hoster with co-location opportunities, where you don't do everything yourself. You get some of the element through some economy of scales. You get, first of all, the building. You get the guy with the dog in the front of the door. You get power. You get electricity. You get network in bandwidth in a shared environment. And the deal that the hoster can have are potentially better than the one you can have. But you lose a bit of control. And finally, the cloud option, which not only gives you a better and higher and stronger economy of scale, and as we will be doing and seeing in a few slides, it also gives you this new fabric, this new type of environment that can be used as is, as if it was a hosted version of what you have, but also can be used specifically and being used in a way that allows different things to happen. So when you bring those two dimensions together, as an enterprise, you start thinking along this map. This map of software that you self-host and home build that basically maximizes the full control. You will have control on the service level agreement and full control on the feature set. You have a choice about running on-premises software that you buy. So then you will be responsible for the SLA with the good and bad element of it. But you get economy of scale from the feature set perspective, but you don't decide the feature set perspective. You might customize it. You might bring a partner in. But it's a slightly different perspective than actually building it yourself. You have the intermediate step where you have software that you build yourself but host at a hoster. And you have software that you buy and have a hoster host for you. And then you have the cloud platform, which is a deployment option that you can leverage for software that you build yourself, as you've seen with Windows Azure and the Cloud Fabric, the Storage Fabric, and things like that. Or you can go for the software as a service model, which is an environment where you take advantage to the maximum economy of scale you can, which is economy of scale from a feature perspective and economy of scale from a deployment perspective. What I wanted to make sure that you understand is that those options are not better than any others. One gives you maximum control, one gives you maximum economy of scale, but each of one of them makes sense. They are all acceptable options. What I make sure that people understand when I have conversation with them, especially if they are architect in an enterprise, is that they need to make those choices explicitly, as opposed to just use whatever is most coherent or the new shiny thing or the things that makes their life simpler. There can be a real conversation here with the business. There can be a real conversation with the vendors and say, for the specific application that I want to have as part of my IT asset, where should it belong? Should I run it? Should someone else run it? Should I build it? Should someone else build it? So to make this a little bit more concrete, I have an example here. An example of this massive enterprise. Think of massive enterprise, pharmaceutical company or a big bank, or, well, big banks usually invest in IT these days. But you can imagine the complexity of those systems, where they have hundreds, if not thousands of applications, and they have a very controlled IT environment. But if you think about how they run their applications today, everything is on premises. Very few or very little of what they run is outside of their corporate boundaries. But they do have this separation between home build and packaged application. So let's play the role for a few minutes of this architect here and thinking, hey, I have this subset of application here that supposedly representing the spectrum of the IT portfolio. And start thinking about those. And let's look at the first one. I have an ERP system. The ERP system is very costly to run myself in this particular example. But I've made two options to actually buy a package out there and getting it as a service. But because I don't really do anything specific and special in the operational aspect of this ERP, let's push it to a hoster. Let's have a hoster run that for me in an isolated mode where I can have control of the data. It's not shared. I have the keys to the room if I need to go and access it. But at least I can get some efficiency in terms of the staff, some efficiency in terms of the physical settings of that environment. Then I think about my issue tracking application that I use in my environment. I think about my email system, and I really realize, oh, CRM. I guess issue tracking and CRM are, should say issue tracker here. So think of those two applications and say, hey, you know what? Those applications are very needed for my day-to-day operations. I cannot run without issue tracking or CRM or email. But really, to me, in my particular context, they are commodity software. I'm not customizing it. I'm not doing anything specific about it. I don't compete with my fellow bank or my fellow pharmaceutical company because I have a better email system than them. So I'm quite happy to push this out and find solutions that are given to me that are offered me as a service. Then I start thinking about my home build application, and I think about my HR system and say, hey, I cannot really afford to run and keep developing this thing. I had to do it a long time ago because I did not find the specific element that I was looking for. I maybe thought 10 years ago that people were really where I wanted to invest, and having an HR system that had the specific functionality in order to do my talent management was what I wanted. But now I realize that a off-the-shelf packaged HR system is fine by me. But because there are privacy issues, and I don't want my data to be seen by potentially others, especially my pay scales, my talents, and things like that, I'm just going to move it up and move from a home build application to a packaged application there. Then finally, I can think about my molecule research environment. And here, I really wished I had more computation power underneath. Every time I run a simulation here, it takes thousands of CPU hours. I really have to provision a overly big data center to run this application. It's not very cost effective because I over-provision my environment. It cost me for 20 days of the month. I'm actually having idle machines there. So what can I take advantage of is pushing it to a cloud environment where the utility computing aspect, the elasticity of the cloud, if you will, is very attractive to me. And then I might decide that this clinical trial here is exactly the application I want to invest. The way I compete against others, the way I really make myself different from my competition is in how I run clinical trial. So let's keep that one in-house, and let's run that one. Let's have all the savings and all the efficiency that I've gathered by moving the other pieces outside of my corporate boundaries and apply them to that particular application. Instead of having 80% of my investments in IT going there to maintain assets that I don't really use, why don't I save some of these 80% in having those run by someone who has more efficiency of scale that I have and apply those to my local resources that I really care about. So this is one of the, in my opinion, in our opinion, one of the big promises of embracing the cloud from an enterprise perspective. This notion of choice, this notion of trying to distribute payloads, if you will, according to the value of those payloads to you. This particular map is a simplified version of what an enterprise might think about. So the way this is distributed is very specific to how that particular fictitious company is thinking. Someone else might actually decide that email is absolutely critical to them and want to run that in-house. Someone else might decide to mix and match those environments differently. So really, just to make sure that the first higher model is understood, oversimplifying a little bit, but I think it's one of the key nuggets that I would like you to go home with, is that things that you want to run on premises is really the one that you want to control the SLA of the application. And there again, controlling the SLA is not doing it necessarily better than anybody else. It can mean doing it better, but it just means that you decide what it is. And if you, in the lower part of the model here for the home build application, regardless of how you deploy it, is for the application where you want to keep control of the feature set. I guess it's fairly simple to get, but I love this model. I've presented this model a couple of times, and I think it helps conceptualize, at least at the highest level, how all those things play together. Of course, it's easier said than done. There are challenges in actually implementing this. Challenges that we as architect, we as developer, have to accept and start mastering. Challenges that the new set of technologies that we've been announcing will be helping. Challenges that in the next session, Eugene will help solve. So what are those challenges? Well, the main and number one challenge is that crossing corporate boundaries is actually very difficult. Conceptually, it's very appealing to move things around. Conceptually, a lot of people would love to just take an asset, pop it from the data center, and put it on Windows Azure. It can be done, but it requires somehow a different way of approaching the problem. It requires the understanding of new technologies. It requires the understanding of new architectural patterns. So this is what we'll be going through at the highest level in the next few slides and go in much more deeper details in the next session. This is not actually dissimilar to this other industry called shipping. When you had in the trains the different gauges, or when you were thinking about the shipping industry or the transportation industry before the containerization of the industry with the ISO container, this crossing boundaries was what was very difficult. There was a lot of efficiency that could be achieved if you could have an end-to-end transportation system where you can start with a truck, put your stuff in a truck to use the road system, go to a big harbor, put your big thing into a ship to go the transatlantic route, and put that in a truck and continue. This is actually what FedEx or the postal system is doing. If you think of the system, they use different set of vehicles, if you will, depending on what they need to do. Between two large cities, they might use the train, or they might use the plane to move letters from Los Angeles to Seattle or Los Angeles to New York. There are distribution hubs where a lot of those letters come in and get redistributed and reshuffled across multiple environments. But at the end of the day, you still have the mailman by foot, by bike, or with a little car delivering the mail to you. So another thing that I wanted to make sure here is that when we talk about the cloud, when we talk about these new technologies, those are not replacements. Those are additional tools, additional options that you have in your tool bag. It's not about, hey, let's all move everything to the cloud, or let's only use access control as my way of doing identity. It's about what is most helpful to me in that particular context. So going further and maybe taking it maybe finally to some of the architectural challenges that we are facing, one that has been elevated many, many times in the previous 4 days or 3 days is the identity challenges. Now you are entering a world where you are splitting your application across multiple dimensions, across multiple deployment options. But your user or yourself, you're still you. You're you when you're accessing an application within your data center. You're still you when you're accessing that application that happens to be run in the cloud. It's still you when you are accessing that application in the hoster. A lot of the technology that we've been using so far, Active Directory, Kerberos, and the like, are very good at managing identity and authentication, authorization within the corporate boundaries. They sometimes fail when you need to cross the firewall. So a lot of the technologies that we're seeing here, and a lot of the patterns that we've been introducing in the last few days, are really about identity, portability, and being able to cross this barrier, this chasm, call it the way you want, between corporate boundaries that we are familiar with and the evil outside world as perceived by many. So things like federated identity, things about claim-based access control, are things that are not optional anymore. If you wanted to embrace this model, if you want to be able to do what I described earlier, being able to optimize your IT environment in placing certain applications in certain places, you need to start embracing the identity at that level. Username and passwords won't scale to those levels, conceptually, architecturally, and also from a management perspective. Fortunately, that technology that we've announced and a lot of learning that needs to happen from an industry perspective that can help you there. We have a lot of assets that can be leveraged for this. The Geneva server, the Geneva framework, if you want to do things yourself, or you can even have a hosted version of that using the access control Windows.net technologies. I'm not going to go too much into those details because, as I mentioned, for those of you who are kind enough to stay for the second session, we will be going in much more details around those. The second challenge is around the monitoring and management. Conceptually, the fact that the application is not running in your data center doesn't really matter to the IT staff, or shouldn't matter. You don't want to go into what is happening today, which is creating islands of management. Many of you have been involved in the SOA or ESB era, or still are involved today. And one of the key elements of SOA was to bring down silos, bring down islands of information, bring down islands of stuff into a coherent and cohesive space. One of the dangers in embracing the cloud is to basically recreate islands that we fought for many years to bring down. One of those islands that can happen is the management island. If now the application I'm using out there, and I'm taking here Amazon Web Services as an example, I could take many others, and the management interface that I'm given is a web page, it works well. I can go to the web page, I can go and look what is happening and whether the servers are up and down, and I'm not criticizing in any way this. The only thing I'm saying is that imagine now you have 50 applications that run out there, 100 applications that run in the cloud. What are you going to do? Go to 50 websites, 100 websites, do screen scraping, understanding, looking at the tags, and if you see the color red in the HTML response, having some sort of alerts? You cannot do that. You need to really understand how you can access this cloud application programmatically and having a unified view of your management environment. But it's not only about monitoring It's not only about the analytics, when it's up and what is down. It's also about interacting with that particular application, sending management commands, trigger a backup, pause that application for a while. Things that are very familiar to an IT operations staff when they think about application within their environment. And the third one, so here again, I mentioned some of that, is being able to programmatically access the health model, being able to send taking transaction when needed, being able to also measure the uptime of that application within your own environment. So this is a nice analogy that I use sometimes. When you buy an application that is offered you as a service, it very often has an SLA. The SLA comes with uptime, and there are penalties for being more down than expected, so on and so forth. But who measures that? Well, often the person who gives you the service measures their own SLA. So basically tell you, I'm going to pay you if I'm down, and actually I'm the one who's going to tell you how long I've been down. It works. It works in many cases. But in other cases, you might be the one counting that. You might be the one deciding how long that particular application was down. So the analogy is like the taxi driver. You go to the airport, and you sit in a taxi. You go to the airport, and basically you pay the fare that is on the taxi. But the taxi is counting how much you owe. Here would be to bring your own meter in the taxi, go in the taxi with your own meter, and at the end of the day, you can reconciliate that fare. And if they match, you're happy. If they're not matching, then you can discuss. But at least you have the power and the data to understand how that application was really running for you. And there's a lot of technology here that we have that can help you with that. And again, Eugenio will be showing you some of that in the next presentation around System Center Operation Manager, the usage MMC, PowerShells, and the way we can actually go through firewalls and think about the application as if it was local, but actually it's running out there. And the third, and maybe one of the most important elements, is about the application integration. I mentioned earlier about the SOA challenges that people have been facing within the enterprise. Those are not going away. As I mentioned, embracing the cloud in many cases is very much like creating those new systems that are not immediately integrated with your own environment. So all the key learning that you've had, and all the books that you've read, and all the scars that you've gotten, and all the sweat that you've produced in working on your SOA challenges are applicable here. Are applicable because you can think about this external system, this cloud environment, as this island, as this fiefdom, or whatever metaphor you want to use for that. And there again, technology that we announced today that have been around, Service Bus, the Azure Storage, and should be SQL Server services, I don't know what triple S is, the Sync framework. So, and there again, Eugenio will show us a very interesting way of doing this with the technology that we just have released. So really, the part one takeaway, if you think about the embracing the cloud from an enterprise perspective, is one, understanding and accepting and embracing this model that you can do optimization of your IT environment by distributing your IT loads across this multiple map. And also understanding the architectural challenges, enable yourself to do that. The challenges that you have to go through to enable yourself to do that are, at the highest level, compatible or comparable to what the industry, the shipping industry, has done with the lowering the transloading cost around identity, around management, around integration. As I mentioned a couple of times already, the second session will be going into the how of this what concept. Good? Okay, so let's move on and look at the ISV perspective. we looked at Massive Enterprise, our canonical representation of the. Let's think about supercloudysoftware.com as our canonical representation of an ISV. And really, in many respects, the ISV perspective is the complementary view of the enterprise. And talking to many, many ISVs in the last few months, there are really two ways, at least, that the cloud can help them. The cloud can be a deployment model. So in addition to their existing on-premises offerings, they can think about the cloud as a service way of delivering their applications. But the cloud can also be a way of thinking about the underlying platform. And those two ways are actually fairly different concepts. The fact that you offer your application as a service does not mean that yourself is running on the cloud. It could mean that, but this is, again, an orthogonal decision. If you're running yourself on the cloud, very often, yes, you offer your application as a service because it's, as of today, quite hard to instantiate the cloud in a data center. But it's not unlikely that over time, technologies that are available and concepts that are available as a cloud fabric will show up in a data center. So the same way I tried to create somewhat simplifying the model, orthogonal decision from the enterprise from a SLA control versus economy of scale and the buy versus build, here I believe ISV have a fairly simple choice to make, or at least a simple model to think about, which is cloud as a way of offering my application as a service, and cloud as a way of offering, of using it as my underlying platform. Am I going to use a server fabric to power me, or am I going to use a cloud fabric to power me? Or, most likely, I'm going to use both. So it's like the server inside or cloud inside the logo you could have on your application. So what are the challenges around this? But before I go that, I forgot about this thing, is really the way you offer your application on premises or as a service is a customer choice, is who do you want to serve. It's not as much what you want to do, is based on what I'm offering, what does it make most sense? If I'm targeting the small and medium businesses, if I'm targeting the consumer, if I'm targeting enterprises, it will all depend on those type of arguments, whether you're going to go and offer your application on premises or as a service, or even better, which is one of the options that Microsoft is taking for itself, is offering the same functionality through both deployment channels. And the other one is really your choice as an ISV, your own platform choice. How do you want to be powered by? So let's look at some of the implications of thinking about the cloud as the underlying platform. Again, one can think about this as a way of control versus economy of scale. It's not the only way, but as an ISV, you can apply the same rules that enterprises apply to themselves and say, hey, do I want to run my environment myself? If I'm offering my application as a service, do I want to self-host and being in a co-location environment where I have to basically manage a lot of stuff? Or do I want to get a cloud environment where I can reduce my capital expenses, I can pay as I go, I can have a much easier capacity planning environment, so on and so forth. And really, the same way we had a continuum in the enterprise space, I think there is a continuum in the ISV space when deciding what the underlying platform should be. And I think this continuum is the server that most of us here have been using and loving, IIS and Active Directory and SQL Server and what have you, that have a very specific way of offering their functionality. Then you have the hosted server, which is basically what you've been using so far, but not run by you. And then there is this new cloud fabric, which is not exactly the same way of approaching it. It offers a new way of approaching the storage, a new way of thinking about computation. So you have to potentially change slightly your programming models and your application patterns, but gives you a lot of different advantages. So really, when I think about this continuum, and when I think about the cloud, I really think about the cloud as two types of instantiation of it, and both are acceptable and both are helpful. The first instantiation of the cloud, if you will, is the hosted version of what you've been using so far. So you don't have to change your programming model. You are used to T-SQL. You're using to store procedures. You're used to trigger. You're using to have ACID. You're used to have transactions. You use the same model on a hosted environment. And then potentially, for some of your application, you decide, you know what? I can relax the transactional constraints that I have. Maybe I don't need to be coherent in every write that I do, but I want to scale much, much, much more than what I do today. Well, maybe then you need to embrace a different paradigm. Maybe you need to embrace a different way of thinking about storage, not for everything you do, but for part of your application. And I will be walking you through an example here that hopefully will give you some of that sense. So I think what is very important here to understand as application architect is, do I want to embrace the cloud, again, as what I already know but hosted? Or do I want to increase my tooling and embrace it slightly differently and benefiting by its optimal design? Again, going back to the analogy I used before, it's not about replacement. It's about what tool do I need for what I'm trying to achieve here. Do I need to move big amount of iron ore from the mine to the port, and therefore the train is what I need? Or do I need to distribute letters and postcards to a neighborhood where I need to physically go and to each of the houses? So this is, I think, one of the, at least for me and for us in the team, has been one of the most important mindset shifts in embracing the cloud in our examples and conversation and best practices, is stepping back and realizing, okay, I used to think about data as if it was all the same. Whether it was a heavy-duty transactional environment or if I was storing images and video, they were very much the same. If the data was very hot and changing every time I open up the web browser or the application, or if it was data that was always the same forever because it was the catalog information or things like that, I was thinking about it the same way. Now, the technology that we are introducing allows you to be finer-grainer, make finer-grainer choices based on the particular attributes of the data you're manipulating, of the computation that you want to take advantage of, so on and so forth. So let's take an example here, and let's imagine we have super cloudy vote. I think voting is a fairly, a common topic these days, certainly in the US. And let's think about how a voting system works. So you can have super cloudy vote being an online voting system. And obviously, when you vote, multiple people vote, and you need to count the votes that people have done. And you fairly quickly go to a concurrency problem. So you have the first thread going there and get a count and say, oh, 10 people have voted here, so you get the 10 back. You add 1 to the count and push it back, and you have 11 now in the shared count. So then the second threads come in, get a count, get 11, push the next count, have 12 there. Then the third one comes in, comes 12. The guy in the middle gets the count again, puts 13 again. So what happens to the yellow one? Well, should be a fairly easy answer. It's either you push 13 again and you lose a count, or you have an exception. Again, I don't want to insult you in a very basic concurrency problem, but I just wanted to sit back and think about this very simple problem and how we can solve it. The classic way of solving it is optimized for consistency, locking, databases, ACID, transaction. Start a transaction, get my number, do whatever I need to do with the number. If someone else comes in, that particular call is waiting on the transaction to complete. I commit my new number. I had to wait for that to happen. I get my number, push it back, and I have the right number. Again, I don't want to insult you in simple transactional element here, but here the pro is the consistency. You can think and program your application as if you were the only one accessing the shared resource, but you have obviously a problem with that is availability. You cannot do the action right away. You need to wait. If you need to wait on a counter, it's not too much. But if you need to wait for a very long set of action, then it might be problematic, especially if your application is meant to scale to hundreds of thousands, if not millions, as a voting system might do. Another way of approaching this is optimizing for availability. Queuing is usually the answer for that. Same example, you get the thread A gets the 12, and the second thread gets the 12 as well. But this time, instead of putting back in the shared resource, basically you put a queue and say, hey, add one or add message into the queue. You have the second guy putting, again, an add to the queue. And then you have a worker that unpiles the queue and adds and basically takes care of this environment. So here you have consistency. Eventually, at the end of the day, you will have the right number. But what you gain here is, I don't have the things there, is availability. What you gain is availability here. You will never lock on what other people are doing. You can, at every single time, you can push your message into the environment. So if you think about how some of the roles that Windows Azure has provided you is very much following that pattern. Because the cloud environment is meant to be used in environment that tend to be facing very large number of users, this concept of availability above consistency is a pattern that will be more and more common. The ACID model, as we will be saying in a few slides, might not scale to the levels that you need. If you think at the highest availability or the highest scalable system that we have out there, very few of them, if any, are actually locking on the requests. They're using queues, they're using asynchronous models, because that's the only way you can actually perform an action that feels happening all the time, while there is a lot of people doing it on shared resources. Another advantage here is that I can scale the workers, the queues, and the websites in order to match my load independently. I don't have to assume that the bottleneck is the data access and scaling up that database and scaling up and scaling up. So again, what I wanted to introduce here is a slightly different way of thinking about how you would do that. And even though you have shared resources, you might not have to, or you might not want to always lock those resources in order to have consistency. Think about a real voting system. What's going to happen in the US on Tuesday. 50 million, 30 million, 10 million, I don't know how many people will vote. They are not actually all locking that particular count every time they vote. They're putting a ballot in the case, whatever it's called, in the box, independently from how long it took from anybody else's to vote. They're putting a message in that queue, if you will, and then at the end of the day, there is this worker getting all those messages and counting independently, making sure that all counts are counted. And then all those independent queues and workers will then combine their own results with all the distributed queues and counters and workers that happen in each voting booth. That's the only way that they can actually have 50 million people vote in a distributed environment. So I don't know how much you can stretch this analogy, but I think the analogy here works in the sense that you cast your vote today, but the results is happening later. So you have eventual consistency, you have high availability, but basically you trade one for the other. Make sense? Is it too simple, like trivial stuff, or actually it helps? Some people are saying, yeah, this is trivial stuff. Sorry. Hopefully you're not the only one thinking that. I have here a very simple demo that I could show just to give you a sense, but I think you understand the concept, but just for relaxing the brain for a little bit. I think I have still this thing running. So this is a little app that I built on top of the Windows Azure thing. Oh, cloud, yeah. Let's see if it's still up. So I was thinking to do the McCain versus Obama thing. Then I said, no, maybe not the best one to do that. I thought about Superman against Batman. That would have been a cooler one. But then I said, hey, let's do something that only a few people would really recognize, is Marmite versus Vegemite. How many Australian in the room? A few? Brits? A couple? Okay. For everybody else, this is two of the most interesting flavored food that you can ever well, some call it nasty, some call it wonderful. So anyway, that's not the point. The point is that there is a big battle between those two in which one is better. So here I have a system, and because I expect millions of Brits and millions of Australians to go and hit this public website to do the vote, I actually implemented that in using the patterns that I described earlier. So I can vote for Marmite, I can vote for Vegemite, I can vote for Marmite, but I don't have the count right away. I have a worker in the back end getting the count and just putting it in the queue. So I can refresh the count. Oops. You see, well, I had 0, so I guess I have a worker that is sleeping once in a while, just to show that there is actually some delay. And if I refresh, things are happening, and maybe there are some people voting in the room because I don't think I clicked twice. And it's still there. So let me just vote for Vegemite again, and just wait a little bit and refresh the count. It's not there. Whoop, Vegemite is there. Come on, man. Or maybe it's like the Zimbabwe voting system. I vote for one and... So I'll stop this one. Let's see what happens. Oh, I have the Vegemite. But what I wanted to also show here is that I can pause the worker. So now I basically simulate a total crash of my data center. So now my processing environment is not happening. So I can vote Marmite, I can vote Vegemite 1 time, 2 times, 3 times, vote, and people in the room might vote as well. And I refresh. That was from the previous count. And yeah, so now I can refresh, and hopefully if I didn't do any mistakes in my code, which is very unlikely, I can refresh forever. It's not going to happen. And then if I resume my worker, and things might be coming in a few seconds, I can refresh, and not yet, not yet. Come on, man, resume. There we go. And I have my guy coming back. So, oh, wow. One guy is like pounding. I don't know who the guy is, but okay. Anyway, enough fun. I'm going to go here just to show you some of the Azure environment. Oops, I need to sign up. Yeah, this sample is actually live. I'm sure there were people like hitting it. So here, just to show you, you might have seen this already many times, but here's my control panel for the application. I can go to my cloud compute thing. This is my application running. And since I'm satisfied with the vote, I'm just going to suspend. And now the application is not running anymore. OK, so that was some fun. Oh, thank you. So the other one that I wanted to spend some time on, and I don't know how long I've got left, well, some time, It's thinking about this as a service model. So when you deliver things as a service, there are other things you have to think about. The things that you have to think about is that most likely you will have consumer or small and medium businesses that you serve, and for serving them, the feature set that you have is sufficient. But most likely, if you serve an enterprise, big pharma or massive enterprise or very big corp, as Eugenia will be showing in the next session, you will need to integrate, as I mentioned earlier, with the identity of the employees. You don't want them to have username and password in your environment. You don't want them to necessarily copy all their Active Directory structure into your own environment, but that better understand the organizational environment that they already have and use that as part of your authentication and authorization system. So this is the usage of secure token services, the token dance, and having some sort of Kerberos ticket being transformed in SAML tickets, so on and so forth. And as I mentioned, also having a management interface to help the IT staff to manage that particular application from within the corporate boundaries. That can be done internally using servers, or thanks to a lot of the technology that we have, internally, almost unknown by the enterprise, taking advantage of the underlying platform assets to implement this functionality. So the fact that you expose and implement a claim-based access control does not mean you need to implement everything yourself. There are some elements that you need to do. It can be very little. It can be integrated into the IIS server infrastructure if you want to, if you chose that path, and basically leverage cloud-based infrastructure component to implement those pieces. So there again, here what I wanted to show is that the as-a-service is what you offer, and the cloud platform underneath is what you might decide to choose in order to implement what you offer. Another thing, since we are discussing like the cloud, what I found interesting, and this is one of the elements that I don't have all the answer. Well, there are many other things that I don't have all the answers, but this is one of them. And is thinking that the enterprise, as we talked earlier, might use the cloud to deploy some of their app. The enterprise might also expose some of their own internal system using the service bus and other technology to their external customers, or in this particular example, you can imagine that the clinical trial patients of a clinical trial system that they kept in-house for privacy reason might need to access it from outside of the corporate firewall. So things like projecting some of that asset through the service bus or the relay or the service bus now, would be an interesting way of using the cloud. But instead of going in deeper in all of those scenarios, what I really wanted to expose here is that the more we're going to move further, the more everyone will have some sort of a relationship with the cloud. The ISV will have a relationship with the cloud as an infrastructure platform. Some consumers will have a relationship with the cloud, maybe because the cloud will be their identity system. The enterprises will be deploying some stuff on the cloud and will have a pre-existing relationship there. So when everybody has a relationship with the cloud, what does that really mean? We don't know fully yet. But if my data as an ISV is in the same cloud than this other ISV, what does that mean? Can I merge and have a combine, and can I help the integration if both me and this other ISV are both serving the same enterprise? They are there anyway, so what can be done there? If as an enterprise I buy two applications from ISV 1 and ISV 2, and both are on the same cloud, what does that mean? Can I have single billing? Can I have a unified SLA? We don't know, but this is one of the elements that I think it's important to start thinking, because right now the cloud is very much seen as a one-to-one relationship. I use it because I need it, and this other person uses it because it's needed. But fundamentally, those two persons are using the same one. There are some elements that can be taken advantage of, either by the individual users or I would expect the cloud over time to be aware of those multi-sided relationships and offer and expose functionality that allow people participating with it to take advantage of. So, as I mentioned, it's likely that the cloud will evolve into taking advantage of this multi-sided nature, even though I'm not sure what this evolution will be. But I think it's an interesting thing to keep in the back of my head, is that you can get advantages over time by just having this relationship. You might take advantage of the cloud because it's helpful to you now, today, from an efficiency perspective, because of a technology that might make sense to you. But by just participating into it, you might be part of an environment that is beneficial to you. I don't know, from a community perspective maybe, from a marketplace perspective. It's unclear to us yet, but I think it's important to be aware of that. So here I have a few minutes left, and I wanted to please the audience, so I have some bonus material. It's like the DVD thing that nobody expected, and there is stuff. And actually, it's actually pretty short, but it's a few emerging patterns that we've seen in interacting with enterprises and ISV and things like that I think are helpful to share early. As a caveat, as a reminder, because the technology is new and the architecture things are fairly new, these emerging patterns might stay, or they might actually also evolve with the evolution of the underlying environments. But those of you who think that are fairly stable and fairly helpful, I believe. The first one is what the community out there started to dubbing it cloud bursting, is really thinking about designing in-house on premises for average load and handle peak as an exception. So really thinking about the cloud as the overdraft or the overflow capacity. Actually, this pattern is, again, fairly simple once you think of it. And it's all obviously been used in the past. And one industry that is using it very often is the utility company. So if you think about PDC, which is the utility company around Seattle, and most of the utility companies, apart from Enron, I guess, that was more interested in off-balance sheet accounting, most of the other utilities produce their own energy that they distribute. So one of the main things that they think about is how much capacity should I generate myself? If I have overcapacity, I have a lot of turbine, a lot of people, I build dams and ruin the environment for nothing. But if I don't build enough, then my customers are not very happy. So what they tend to do is they compute and they survey the average load that they will need to generate. And then they basically fluctuate around that average load by trading, selling, and buying electricity from the grid. Again, it's a fairly simple patterns here, but it's possible, and actually we've seen a couple of companies doing that for their computing environment. This is not very dissimilar to the grid computing promise that has been around for a few years. I think now it's just going to be much more common with the access to cloud computing and cloud storage being democratized by some of the technology we announced today, that people will do capacity planning in a different way. Instead of doing capacity planning in a very sophisticated way, they might do capacity planning in whatever they want to invest as part of their environment, and then fluctuate around that dynamically, offloading and getting things from the grid. The setting power back to the grid is actually a very complex system in computing, but buying power from the grid is actually something that it can be done fairly easily. An example of that, and to be honest, I'm not sure that we are doing this at PDC, but it's a perfect example that of cloud bursting. You could imagine that the session of encoding, so this session is being recorded, and you can imagine a system where the raw file is placed in a blob, and a message is sent to a queue saying, hey, I've moved that particular raw file into a blob. And then you have a worker, independently, and eventually picks up the message, transcode the file in multiple formats, the Zune, the high def, the low def, sound only, what have you. Place the files back in various blobs, put a message into a queue with pointers to those blobs, have another worker coming in, picking up the messages, and construct a web page pointing to those different blobs that have been created. And the thing here is that the worker in queues and blobs can be scaled independently, and the infrastructure that you need to make that happen is very time dependent. You only need to do that, well, only for PDC, only 5 days in a year. You only need to do that at the end of each session, and you don't need to do any of that at night. So you could imagine a model where you spin up that particular infrastructure, the workers, the blobs, and the queues, and things like that. When you need them, you do the work, and you shut it down. So this is an example, a fairly simple example that anybody can implement once contextualized in their own environment, where cloud bursting is a good usage. Yeah. Another thing here, and how many of you are familiar with CAP? A few, 1, 2, 3. I discovered that only, to be honest, a few months ago, and I was very angry because this has been published in 2000, 8 years ago. And I said, oh man, I thought I was at the top of my game and I knew the stuff, and there are people obviously very much smarter than I am, and I've been thinking about all those things a very long time ago. The professor who actually described this theorem is a professor at UC Berkeley. He's also the founder of Inktomi. So for those of you who remember back in the days when the web was emerging and nascent, Inktomi was this very massively distributed search engine and caching engine. And obviously, in order to implement that, they had to think very much about high availability and the boundaries between consistency and availability. So basically what this theorem is saying, or I think it's a conjecture, I don't know if it's been proven or not, but in practical terms it works, is that, it means that you can only pick 2 out of the 3. You cannot have consistency and availability and tolerance to network partition. If you distribute your environment, you have to think either consistency or availability. This is pretty much the theorem or the conjecture that is behind the little example I gave versus whether you want to optimize for locking or you want to optimize for availability. One is more queue-based, and it will give you the eventual answer at the end, but you can always do that. Or the other one will always give you the right answer, but might lock people while doing this. And this actually gave birth to something that I found funny the first time I found it, and I wish I was the inventor of it, but I'm not, is that we all are familiar with the ACID property of databases. Well, this CAP theorem and this eventual consistency is, if you will, the complementary aspect of ACID, which is base. For those of you who are not familiar with chemical things, acid and base are the 2 different complementary things bring together, makes what? Salt or something? Anyway, as you can see, I'm not very good with my chemistry book. But the point here is that what is more interesting is realizing that even though most of us, and me included, have been thinking a lot, and maybe from the beginning in my many years of development, mostly data as transactional and ACID, there are now more and more reason, especially because of the availability and scalability requirement, to also think about data with this base environment. So here as an example, I'm going back, sorry. An example I think can illustrate that one, again, is not better than the other, but both can be used at the same time. So here is an example that I think will exemplify this properly. Think about the shopping life cycle. When you do shopping and you have a shopping cart and you are the provider, you're the e-commerce provider of that, the very last thing you want to do is not having your shopping cart available. You don't want the person trying to put something in the shopping cart and say, oh, wait, someone else is trying to put something in their shopping cart, so why don't you wait a few seconds while this other one is done so that I can put yours. It would be the equivalent of someone going into a real store and trying to put something in the bag and one will say, oh, no, wait, the the queue there is too long. Can you wait before buying this? So everything that is customer-facing, everything that is really an event that generates money for you has to be availability-driven. A lot of the shopping cart implementation today in very large e-commerce systems just write all the time. They don't care if the data center is on fire. They usually don't even know if what you're trying to buy is available. They have a heuristic or they have a cached version of how many of the copies of whatever you want to buy is available, and they sort of assume that it's available for you to purchase, or even sometimes don't even care if it's available. They're just going to sell it to you and deal with that later. So for this part of the life cycle, it's important to optimize for availability. But once the shopping is over and you grab those items from the real inventory, then it's important to actually be consistent. You don't want to grab inventory and then assume there are things there. You really want to have a real number, the real count, if you will, of that. But while you're doing it, which is a back-end process, it's okay to wait a second or to try to grab something from inventory and it's not available for you to do anything, so you wait, you do something else instead, and try to do it again later on. So there again, the same sort of data, the same sort of process, using a different pattern where consistency now is important. And finally, when the thing is one shipped, and you just want to store a reference to the shopping, you just need a key that points to a blob, if you will, of what has happened, and that thing will never change. Then you can store it in a completely different system where you know you're not going to transact on it, you know you're not going to change it, you know that it's read-only, you can put it in a different fabric underneath than what you use for the other pieces. So again, here the idea is that some tools, same tool for each, I cannot read anymore, same tool for each of these is not optimal. Being able to understand the attributes underneath of each element and decide what to use underneath is important. So you might use SQL Server for one piece of that, for the consistency. You might put element in Windows Azure storage for the others. Again, this is some of the elements that I would like to start introducing, that maybe you've been thinking about this for a long time. And very quickly towards the end, the heuristics of cloud friendliness. This is some of the elements, some of the patterns we've seen. The more the data is read-only, the more data is public, the more data is reference data, which means it doesn't change much, and the more you can access it primary key, the more it will be easy and natural to put it in a cloud fabric. Think of it as maps, profiles, blog entries. It's not coincidence that the Facebooks of the world and the application like that are the most bigger consumer of this type of applications, because the data they manipulate is very close to this. When you're updating your profile on Facebook, you have multiple copies of your image. One that is pushed in Japan for your friends in Japan, one is pushed in Europe for your friends in Europe. And when you upload your new picture, you don't want all the pictures to be updated at the same time. You don't really, it's not that important for you. So you upload one, it works, and then it's going to be replicated in the back. So again, this is my final slide for this particular session, is really thinking about decomposing your environment in terms of, I was thinking about this thing, either my IT environment or my solution architecture or my data or my identity, as if it was only one, and start thinking a bit more as a continuum of things and deciding with the different technology that I have underneath and using the technology underneath that has the attribute that best matches what I need that particular entity to be supported from. So I could not finish my presentation without an anti-pattern, which is the one also we've seen a lot. And I think the number one anti-pattern I've seen in the last few months is this one. It's basically people thinking that, yeah, this actually, I've known this for a while. This is things that I've been working on for quite some time, or even worse, or this is a hype, this is things that never will impact me, so I don't really care. The good thing is, if you've been here and you've been coming to PDC, you're not one of this person. But I think it's one of the challenges that many people will have, and maybe some of your colleagues or some of your bosses, will potentially be in this situation. So I think it's very important for us, for an industry, to realize that there is some changes, accepting those changes, and really embracing those changes in doing the right thing at the right time. With that, I just wanted to remind you of what the next session is about. The next session is Eugenia, going into much more details in some of the elements I've discussed, and actually opening a Visual Studio for once, and maybe, and showing you some of the guts behind some of those things. Thank you very much. So evals, you know about this, and Q&A. Yes, sir.
Yes.
Yeah, go ahead.
Yes, hello. Yes. So all the vendors of cloud computing solutions tell us, can you hear me?
Yes.
Yes. Okay. So all vendors of cloud computing solutions tell us that when we put our data on the cloud, they are secure, confidential, etc. So Google says that, Amazon says that, or now you say that. So my question is, could you, as Microsoft, put your data on a Google Cloud or on Amazon Cloud?
So the question is, am I on? Yeah. So the question is, since everybody is secure and confidential and things, would Microsoft push our data on the Google Cloud and things like that? Well, I don't think we would do that, mostly for, again, a control perspective and a business perspective. We would not have an advantage to basically do that because we want to have the data underneath. This said, you as a solution builder can mix and match among those multiple platforms. So something that I did not talk about because it's not really to our advantage in some respect. But we're doing everything we need to do from an interface perspective, a protocol perspective, a standard compliance perspective, to create those components in such a way that you can build your own cloud. Microsoft will come in with their own version of the cloud, which I believe it's, well, we hope it's what you're looking for. But it's not unlikely to think that you as a solution builder, we realize that, I want identity from those people, data from those people, and compute from them, and you're going to pretty much create your own instantiation of those components that better match what you need. But because you're going to be dealing with multiple different providers, the additional somewhat complexity of those multiple. You might get different bills. You're going to be charged for one differently from the other. You might have to have multiple relationships to manage. But the question is, if you store something with us, we're going to store it in our environment. Now, you can have what we compute out and store it elsewhere if you want to. We are not linking all those components together. We hope that together they are better, but they are disjoint if you choose to do so. Sir?
Yeah. In cloud, multi-tenancy is one of the major factors.
Multi-currency?
Multi-tenancy.
Or multi-tenancy, yes.
Right. So how this is being taken care of? That's not explicitly discussed on.
Okay, so multi-tenancy, and we've done a lot of work there. I don't think it's a cloud-related specifically. Multi-tenancy is an application platform. It's an application pattern that you implement regardless if yourself is hosted on the cloud or on servers. So you can have a multi-tenant app running on servers. You just need to design it that way. This said, there are elements in the cloud that we're offering that facilitate the implementation of the multi-tenant patterns. For instance, one of the things that is very important in multi-tenancy is being able to customize entities differently for each of the tenants that you have. If you look at how the entities are implemented in the SQL data services, it's a bag of properties. So you can have an entity that is defined one way for customer A or tenant A, and the same entity defined a different way for tenant B, but being manipulated by the same computing engine. So what I'm trying to say here is the cloud environment that we have is familiar and friendly to multi-tenant patterns, but multi-tenancy is an application pattern that you need to implement as part of your solution architecture above and beyond all. It's not something, click a button and say, make multi-tenant. Does that answer the question? Yeah. Yes? Oh, absolutely, absolutely. But it's something you need to explicitly want from the platform.
Yes. So I understand, a number of the issues that you face that you just mentioned about this. So I'm just wondering if you're thinking about a couple of things. At least from the things that we see as an ISV, very few of our customers have a single technology stack. Mm-hmm. So, so let me give you an example. Mm-hmm. So let's say we provide a SDK.NET that either we or the customer builds an application on top of, right? Their mm-hmm. choice.
Sure.
But they're accessing their local data, which might be stored in Oracle. Now, they say, well, we don't necessarily want to host this thing. So what would happen in that? That's a very simple mixed technology stack there, right? How's that data going to get, moved into your cloud, or is that just not an option?
No, it is. So obviously, I will need to know more of the details of the environment. But one of the things that I hope I was able to convey, and certainly what we want to convey as Microsoft as a whole, is cloud and on-premises are not disjoint. Mm-hmm. They will be today because it's still nascent, things are still happening, we don't have all the technology ready and full and done, but we're moving there. We want this cooperation to happen. So if you look at technologies such as the data synchronization framework, if you went to a couple of sessions, I think Dave Campbell did a session where he had SQL Server, SQL data services, and he might have even had some data on a mobile devices, and those things are actually being replicated and moved around. The cloud cannot be a barrier, cannot be an island. If it ends up being an island, we failed as an industry, because it is very fundamentally an extension, additional tooling environment, if you will, another way of doing certain things. It's like today you've been using the hammer and the screwdriver, now we give you a sledgehammer. The sledgehammer will not be replacing your hammer, it will give you an opportunity to do other things. Now it's up to you, based on what you're building, to use the right tools. So if you're building a house, you're going to start with doing the foundation with the sledgehammer, and then when you're doing the painting things, you use the hammer. So I'm not sure that my analogy works well here. But it's very important to understand that this multi-technology, on-premises cloud things is very much a priority for the way we're thinking about the platform.
Well, I guess maybe the most general form of my question then gets down to be successful, people have to be willing to apply this, what it seems like a single technology stack to their solution, or be willing to use it as a piece environment, in which case they're still involved in the hosting paradigm themselves, right?
Yeah.
So that's their choice. That's the choice.
Well, I think it's with any technology. Either you decide to have one technology, or if you want to embrace multiple technologies, you need to understand how those technologies work together. We're doing everything we can to make those technologies work well together, but it's an explicit choice that you need to make.
Yeah.
Okay, maybe we can discuss later.
Yep.
Okay, thank you. Oh.
Hi. You had a slide initially that said one of the sort of options is to take your existing app, whether managed or unmanaged code, and move that into the cloud without a lot of adjusting for storage and queuing and all that sort of stuff. Can you describe that again? Is that like just getting your own virtual machine up on the cloud? And
no. So as of today, if you're going to play with the bits, it's not a virtual machine hosting environment. Yeah. It's well, it depends on multiple things. Like the storage, which is separate from the compute. So it's so you have to differentiate between what we are showing today as a CTP for people to get access to and play with the bits and give us feedback, and what will be eventually happening. As of today is managed code only. Okay. So what you're going to be able to play with the CTP is a container for ASP.NET app, WCF apps, so .NET apps. Over time, people in the product teams and Manuvir in this presentation said, we want to support native code as well. So there will be a period of time between what we have available today and what will be available there, and that will be the difference. As of today, you take pretty much any ASP.NET app that you have. You can package it, recompile it using the tool that we have, and it will be running on our cloud. From a storage perspective, it's slightly different. So the storage that we have here, the one we are exposing today, is more about entities, flex entity that you manipulate. There is no notion of T-SQL. There's no notion of transactions. It's a different way of approaching it. Over time, we will see. So as of today, there is some explicit programming model that you need to adapt, to accept. And over time, things will get smoother and smoother.
Thanks.
Yeah. I don't know how much time we've left, but happy to do as many as
I think it's similar.
2 more minutes. So one question, last 2 questions, and then we can continue conversation.
If there is an ASP.NET application that communicates today with a relational database, and we want to move that to the cloud, we understand that we will not be able to use the database connection as it is. Would we need to go back through the service bus to our premises for the data fetching? Wouldn't that be very slow on the performance?
No, so, well, it will depend on the specific. It's true that we would not have, as part of the CTP, a hosted SQL fully fledged environment. So your ASP.NET will have to connect to a database that is not in our cloud. So you have 2 options. One option that is usually not very appealing, which is rewrite all the database access and so procedures and what have you in embracing the fabric that we have. Or you host the database externally with an external facing endpoint or a web service interface that exposes those functionality, but then you pay the wide area network delay.
But hello? Interfacing it externally means outside of the cloud, right?
No, yeah, but from within your ASP.NET code, you can call out. That is allowed to you to do, but the database itself will not be collocated with it.
Not even in a VM or in the cloud? No.
Not today.
Thank you.
How would that work? What's the longer term of that?
The longer term will depend on the engineering. It's likely, it's possible. There's nothing we can commit to it yet, but we will see. It also will depend a lot from the usage of it. Very last question. I need to leave the floor. Yes, sir.
Good presentation.
Thank you.
So you talked about data synchronization. Are you talking about feed sync, or is this something different?
No, feed sync is one way of synchronizing feeds. So that's part of the mesh environment. But there is a data synchronization framework, which is separate from that one, that synchronizes data on a different type of data. It's not the feed sync.
Is there a code name for that, or how do I know what that is?
The code name for the data synchronization framework is a sync framework? Yeah, do you know a code name or something? No? Sync framework? I think it's the same framework. I don't know of any other. I can point you to the exact build if you want to.
All right, thank you.
Okay, sure. Well, thank you.